One place where we use this how many ways can we is in probability. Let's switch gears just a little bit for probability, and I'm going to start with the easiest, and that's the flip of a coin. So a coin either has heads or tails. So probability is the number of desired outcomes divided by the number of possible outcomes. That being said, if I say what's the probability that I flip a coin and it lands on heads, there's only one desired outcome, that being heads. And how many possible outcomes are there? There is 2, because it could land on heads or it could land on tails. So if I have a 6-sided die, then the probability that I roll it and it lands on 2, the number of desired outcomes is just 1. The number of possible outcomes is 6, because there's 6 different numbers. If I ask what's the probability that it lands on an even number, the number of possible outcomes there is 3. That's 2, 4, or 6. The number of desired outcomes is 3. Pardon me. The number of possible outcomes is 6. So that probability is 1/2. The probability that it'll land on an even number. Same thing for an odd number, because there's 3 possibles out of the 6. 3 desired out of the 6 possible. I keep saying the wrong thing. Alright, so then, what if I have 2 dice and I throw the 2 dice? So, here's the number of possibles. The first die can land on 1, 2, 3, 4, 5, or 6. The second one can land on 1, 2, 3, 4, 5, or 6. So we add those up. 1 plus 1. So I might possibly roll a 2, or a 3, or a 4, or a 5, or a 6, or a 7. You can see this chart in your book. 3, 4, 5, 6, 7, or 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, and 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, 12. So you can see from this that the most likely outcome when you roll 2 dice, the most likely outcome is 7. 7's has a greater probability because 1, 2, 3, 4, 5, 6 times, 6 possible out of how many, or 6 desired out of how many possible? I'll let you count those up. Give you a second. It's 6 times 6, which is 36. So the probability of rolling a 7 when you're rolling 2 dice, if you only got 1, the probability of rolling a 7 is 0, because it's not ever going to come up. But if I got 2 dice, I got 6 possible out of 36 6 desired out of 36 possible. So you got 1 in 6 chance. The probability that you roll a 10 is going to be 3 out of 36, or 1 out of 12. The probability that you roll a 2 is going to be 1 out of 36. The 2 and the 12 are the least likely to happen. Yeah, the probability that you can roll something less than 4. The probability that you would roll something less than 4. Well, that would be 1, 2, and 3. 3 out of 36. 1 out of 12. All right, so let's look at our heads and tails a little more. When we flip our coin, one flip has nothing to do with the next flip, okay? So they are independent events, but we can find the probability of multiple of those independent events. On my first flip, I can land on either heads or tails. And we already said the probability of that is 1/2. The probability of heads is 1/2 right there. On the second flip, we can also land on heads or tails. That's my second flip. On my third flip, I can also land on heads or tails. So, this is my third flip. So I could flip a coin 3 times and I could get heads, heads, heads. I could flip it 3 times and get heads, heads, tails. 3 times and get heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, head. Or tails, 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 tails. So I have possible 1, 2, 3, 4, 5, 6, 7, 8 different possibles. 8 possibles. So if I said, what's the probability that I flip the coin 3 times and it lands on heads every time? Well, there's only one desired. Only one of those has heads every time. So the probability of all heads is 1 out of 8. Well, if we look in that first flip, the probability of heads was 1/2. In the second flip, the probability of heads was 1/2. And in the third flip, the probability of heads was 1/2. If I multiply those 3 probabilities together, then that gives me 1/8, which is the probability that it all lands on heads. So if we flipped it a 4th time and we wanted all heads on the 4th time, then it would be 1/2 times 1/8, which is 1/16. So let's look at a practice problem here. A is there's 3 chairs in a row. There are 7 students. How many ways can these students sit in the 3 chairs? So not everybody's going to be able to sit because I only have 3 chairs. So here's my 3 chairs. 1, 2, 3. I got 7 students. So for the first chair, there's 7 possible people that can sit there. Once one has sat, then there's only 6. And then there's only 5. 6 times 5 is 30. 30 times 7 is 210 possible ways that those 7 students can sit in those 3 chairs. B says Roger rolls a pair of dice twice. What's the probability that in 2 rolls he will get a total of 7 on the first roll and a number greater than 9 on the second roll? So we're doing a probability of 7 on the first roll. You remember what that was? It was 6 out of 36, or 1/6. And we're doing the probability on the second roll of greater than 9. If you still have your chart, we had 36 possible over here. Greater than 9 was the 10s, which there was 3. The 11s, there's 2, and 1 12. So that's 6 out of 36, or 1/6. So we multiply those together, and it's 1 out of 36 chance that on the first roll we roll a 7, and on the second roll we get a number greater, a sum greater than 9. All right, thank you very much.